Okay. Previously we discussed the demand for real money balances as explained by different economists such as James Tobin and William Baumal. Now we are going to have a numerical example on demand for real money balances under the Baumal Tobin's theory. Now we have a question. Assume that Peter earns a nominal income PQ each month and it is deposited in his account in the bank at the beginning of each month. Each time he withdraws money, he incurs a nominal fixed cost PB, and each time he withdraws an amount equal to M star. The interest rate is R. They are tasking us to derive the expressions for the following. 1. The average amount of money held during the month. Okay. Now, as we explained yesterday, we said that we have two ways of optimizing. We can optimize the amount of cash withdrawals. Whenever we go to the bank, we withdraw a large M star. Or we can optimize the number of trips in order to minimize costs. Now, when we go back to this question, they are saying they want to optimize the amount of money to withdraw on each visit when you look at question 4. Okay, that means the average amount of money held during the month are going to be in terms of M. Okay, so part A, average amount of money held is going to be equal to, if we can analyze the question, they have said that assume that Peter earns a nominal income PQ. So we have nominal income, we have nominal income is equal to PQ. We can say given nominal income PQ, and it is deposited in his account in the bank at the beginning of each month. Each time he withdraws money, he incurs a nominal fixed cost. So we have nominal fixed costs is equal to PB, and each time he withdraws an amount equal to M star. So withdraws an amount equal to M star at an interest rate is equal to R. Okay, that's what we are given. But remember, if you can say part A, the average amount of money held, average amount of money held is equal to Y over 2N. That is the formula. But remember, N refers to the number of trips to the bank. But how do we get the number of trips? The number of trips, N, is equal to the amount that is in the bank divided by the amount you withdraw towards each trip. That means it is the PQ divided by M star. Right? So in this case, Our Y is the income that is deposited. So Y is still equal to PQ. So we can now say that our average money holdings is going to be PQ divided by 2 into N, but N is PQ over M star. Good. So we can solve this. This is going to be PQ divided by 2 PQ over M star. We can make this a fraction out of 1. So this is equal to PQ out of 1 times M star over 2 PQ. Right? So this PQ can go with this PQ. We get our average amount of holding money. Average money holdings is equal to M star over 2. This is PQ. M star over 2. Okay. M star over 2. Average money holdings is equal to M star over 2. That was our part A. Now part B, or Roman 2, is asking the transaction cost for the whole month. Roman 2, transaction cost for the whole month. Transaction costs for the whole month. But transaction cost by formula, transaction cost, we can call them the TC, small tc, is equal to the number of trips to the bank times the fixed costs. But fixed costs, there is a nominal fixed cost PB, so it's going to be N times PB. But we said N is equal to PQ divided by M star. So our TC is going to be N, which is PQ divided by M star times the PB. So the transaction costs are going to be PQ PB divided by M star. Those are the transaction costs. Roman 3. Roman 3 is asking the opportunity cost of holding money. The opportunity cost, the opportunity cost of holding money. The opportunity cost of holding money is the interest you forego by holding cash. That means it's going to be R times the average money holding, which is now M star over 2. So the opportunity cost of holding money is equal to R M star divided by 2. As simple as that. And then the optimum amount of money to withdraw on each VIST. Now to get the optimum, it means we are going to get the first order condition by differentiating the total costs. Because we get the optimum amount of money by minimizing the total costs. But that is our Roman 4. You can have the next page. The total costs are the transaction costs plus the interest foregone. Plus the interest foregone, or the opportunity cost. So the total costs are equal to the transaction costs, which is PQ PB divided by M star, plus the interest foregone, which is the interest rate, times the average money holdings, which is M star divided by 2. So to get the optimum amount of money to withdraw on each visit, that means we are going to take the first order conditions. But we can't take the first order conditions when we have M star as a denominator, because we are going to optimize the number of, or the amount of cash withdrawals. So we can play with the mathematics to make this one a numerator. That means our TC is equal to PQ PB M star to power -1 plus I M star divided by 2. So from there we can take the FOCs, the first order conditions. So the TC, the M star, at first order condition we equate to 0. When we differentiate this function with respect to M star, we are going to get a negative PQ PB M star to power -2. So partial derivative of I M star divided by 2, we get a plus I over 2. Remember, it is equal to 0. So if I take this on the other side, I get PQ PB M star to power -2 is equal to I over 2. I can make this positive by making it a denominator. That implies PQ PB over M star squared is equal to I over 2. Okay, so I can now cross multiply to get PQ PB, which is equal to M star squared I. So I can divide by I divide by I get M star squared, which is equal to twice PQ PB over I. But I want the optimal M, so I can take power a half. What I do on the left hand side, I do it on the right hand side. So I get M optimal as the square root of 2 PQ PB over I. So that is the optimum amount of money to withdraw on each visit. Now, to get the Baumal Tobin's demand for real balances, we substitute this optimal M into the average money held during the month. So the Baumal Tobin's demand for real balances are equal to Baumal Tobin demand for real balances are equal to Baumal Tobin's demand for real balances are equal to, so from M star over 2. Now this M star is going to be M naught. So our M naught is 2 PQ PB divided by twice I to power a half. So this goes with this. We get PQ PB over I to power a half as the Baumal Tobin's demand for real balances. This is nominal income, nominal fixed costs, and interest rate. That's why I told you yesterday that Baumal Tobin demand for real balances is a function of 3 key variables. That's the nominal income, nominal fixed costs,